So, welcome back. After seeing this process, the phase change process at constant pressure, two phases in equilibrium that we saw in a PV diagram. So, let us have knowledge about these two phases staying together in equilibrium, and for that let us refer to this PT diagram and PV diagram, let us say. So, again let us have a LV saturation line here, and we had seen that we heated a subcooled liquid from 20 degree centigrade and went up to 300 degree centigrade. I am showing just those points from 20 degree centigrade to 300 degree centigrade, and this process change has happened at 1 atmospheric pressure, and therefore the boiling point here in this case is 100 degree centigrade. So, here on a PT diagram I have shown the first point from where we started 20 degree centigrade and the point V, and again on this P, any property I have taken here on x axis, which could be U, V, H and S, thermal energy, specific volume, enthalpy or entropy. I can take any of these properties. The point is, because we have taken 1 atmosphere, we can locate 100 degree centigrade, which will lie on this LV saturation line, and corresponding pressure is 0.10142 MPa, and this was our starting point. If I extend this constant pressure line, it will pass through these LV points also, which depict the subcooled region and goes up to superheated vapor region. Now, when I started increasing the temperature from 20 degree centigrade, the phase change happened at 100 degree centigrade, and because we started from liquid region, the first point I hit is a saturated liquid line. So, corresponding properties of liquid can be obtained from the steam table, and these points are normally referred to as with subscript F. So, saturated liquid giving subscript F, and corresponding properties at this point are UF, which is thermal energy, VF, which is specific volume, HF enthalpy, and SF is entropy of the liquid, which is on saturated liquid line. So, correspondingly, if you see on a PV diagram, if I say I have taken this property as V, this is my saturated liquid line, this is saturated vapor line, both these lines merge at critical point over here, and this point on this line what we see is 100% liquid, on this line what we see is 100% vapor. So, we are talking about this F point now, but this F point will be viewed as the same point when I see from this angle. In PT plane I will see as a point because both G and F actually coincide, and I therefore cannot differentiate between F and G point on a PT diagram, and because I want to differentiate between them, I have to refer to a PV diagram, alright, or a PU diagram or a PH diagram as shown over here. So, the first point I hit is saturated liquid line, from where the phase transformation starts, and it continues from point F to point G, where 100% liquid now will get converted to 100% vapor. The properties at this point, at point G, are given with the subscript of G, and they are given as now UG, VG, HG and SG. So, here G denotes dry saturated vapor, alright. It was saturated liquid here, now it is a dry saturated vapor here at this point, and this length actually denotes the latent phase transformation, alright. So, this enthalpy difference actually shows the latent heat associated with this phase transformation, and it will be different at different pressures. At 1 atmosphere we have got a latent heat of water at 1 atmosphere. As you go up the top, this latent heat will start decreasing. The point to be noted is, in the steam table now we will have values for saturated liquid region giving as F as subscript, we will have properties at saturated gas region with the subscripts of G, and any point in between this F and G actually is a two phase mixture. Two phases are in equilibrium, there will be liquid region and there will be a vapor region, depending on where it is, because we are starting from 100% liquid to 100% vapor. So, depending on how close it is on the left side or at the right side, the proportion of liquid and vapor will vary accordingly. What is important to note also is the difference between UG and UF, VG and VF, HG and HF and SG and SF. The difference between HG and HF is nothing but HFG, which is given over here, and these two values, the HFG and SFG, are given in the steam table directly. Because we deal with those values directly, they are given in the steam table, but they are the difference between HG and HF, which can also be directly read from the steam table. While delta U, sometimes referred as UFG, delta V, sometimes referred as VFG, can be calculated because we know the value of UG and VG, and also we know the values of UF and VF. Alright. Again, point to be noted is, as the pressure increases, this delta U, delta V, HFG and SFG start decreasing because this length get decreased, and you can notice that at point Cp, the UF will be equal to UG, VF will be equal to VG, HF will be equal to HG and SF will be equal to SG. So, delta U will be equal to 0, delta V will be equal to 0, HFG will be equal to 0 and SFG will be equal to 0 in that case, and this is what will happen at critical pressure at 22 MPa and 373 degree centigrade. Thank you very much.